So tonight, what I'm going to be doing is we only have an hour, so I'm going to take a very simple machine learning model. I'm going to try to do end-to-end. Hopefully, we're going to be able to do, a first quick pass, and then, go back to our code and process some improvements. So I'm just going to open a buffer. There we go. You can put some Python mode, and then can activate PySpark, start my environment. Okay, we're probably ready to get started. So I'm also going to open a REPL. I'm not a big fan of notebooks. I find it a little bit easier to use development environment. If you are lucky enough to be able to work on a Databricks environment, there's Databricks Connect that you can use. Otherwise, usually what I do is I develop my code and then I promote it. I find, with the exception of a few experiments, I find that I'm more productive when I have all my keyboard shortcuts. All right, let's get started. Oops, I'm misaligned. So from PySpark, let's SQL. Should probably, there we go. I'm just going to zoom in. It's going to make stuff a little bit bigger. PySpark SQL import Spark session, and then Spark equals Spark session. Name simple and to and ML process. All right, okay. Perfect. Now, what do I want over here? I'm going to customize my driver. I'm using Spark locally, and there's a good reason for this. First of all, I don't want the round trip. When you're working with big data, it takes always a little bit more time. And if you get to think of it, if my ML model takes more than a few seconds to train, we're still going to be there very late. But the process is still the same. Memory. And then I'm going to use, what the hell? Let's do it 8 gigs. All right, perfect. So I'm going to do this. And then before I get everything up and running and starting, I'm just going to get my data set. So for those who have are current with my book, I'm going to reuse the data set that is, if I'm not mistaken, in chapter 10 or chapter 11. I know we reorganized some of the material recently. It's basically the data set that contains a ton of recipes, and we're going to try to predict if recipe is a dessert. So I'll show you the shape of the data frame, but you're going to see it's a very easy problem. The goal here is not to pick something that is going to take forever. So I'm reading the data. We have a CSV files. I'm inferring the schema, and there's also a header in the data. As we're going to see, the data is not fully clean, but it's still going to give us a good sense of. There we go. So send my stuff. There we go. Yes. Here we go. If I'm not mistaken, this is where my data is now. Perfect. All right. So I'm going to do a little bit of exploration. I'm just going to get this a little bit bigger. Over here, I have my my iPad, where usually when I code, I always keep a notebook with me if I need to remember stuff. So now what I'm going to do is, there we go, this way. And I'm going to move to, I'm just going to make sure, there we go. This way, it's going to be easier to show everything. So if I do a print schema of my food, you can see that basically I have a ton of variables. I'm going to go all the way up to the top. So we have the title, we have the rating, the calories, protein, fat, sodium. There's a hashtag cake week, hashtag wasteless, and then a bunch of features. So the one that we're going to be focusing on is there is an attribute that is called dessert, which is a little bit down on the D's. A couple of things that I want to show is some of the features, because the CSV5 can pretty much contain like any types of character, having a little bit of an issue. You know, there's some characters that don't appear either because, and as you can see over here, like it's a good example, like we have the bon appetit, and then you have a bon app blank blank tit, which, you know, can have, there's a couple of data quality issues. I'm not going to address them at first. I just want to see, you know, what the data contains. But eventually, you know, this is something I would spend a little bit of time. So if I am dessert, there we go. This is the target that we're going to be looking at. So of course, you know, if you're looking at this, if you're taking an example like eggplant, there's a very good chance that no recipe that contains eggplant. I mean, as far as I'm concerned, never had a dessert that contains eggplant, but it gives us, you know, good blueprint to be able to get started. So, all right, now I'm just gonna go and you know, I'm just gonna go down. There we go. And what I'm gonna be looking for is food. There we go. Print. I'm gonna look at food, the count, and then how many. What's the length of the data frame and the width of the data frame. So I have a little over 20,000 records, 680 columns. A lot of them are going to go because either they're not useful or they don't contain something that is relevant for us. So the first thing that I'm going to do is I'm just going to clean, you know, the I'm just going to clean the I'm drawing a blank. I'm going to clean the column names. There's a couple of characters that I want to be able to remove. Basically is I have space that I'm going to want to replace with, actually. There we go. It's probably going to make sense. I have a space that I want to replace by an underscore. There's going to be also a hyphen that I also want to replace with an underscore. And then there's going to be a slash, I'll replace with an underscore as well. There's the ampersand, ampersand where? There we go. That I'm just going to replace with and. And there we go. And then I'm just going to wrap this over here, up. There we go. And then I'm just going to put that overall here into a list. And then, so this is basically where I'm going to want to replace this. And basically what I'm going to want to remove is also all the characters that are not either letters or digits, or the underscore, obviously. So I'm just going to create a quick function, clean columns, name, then here we go. Usually I'm pretty keen on, so this is a cleaning dictionary. There we go, up. Perfect. And then for before, after in cleaning dictionary. There we go. Answer, replace before and after. So before we get there, answer equal name. I'm a big fan. I don't know, it's probably something that I don't know where I picked up, but I call my return value answer. And then now basically what I want to do is I want to filter everything that is, so return this, so a character for character and answer. If my character is alphanumerical, or the character is a digit, or character is equal to an underscore. And now this is going to return me a list. So basically what I'm going to do is I'm just going to use that neat little trick with, there we go. I should probably, there we go. I'm just going to make sure that just want to, there we go. That's going to make it more sense. So, all right. I think that this all makes sense. Now, I'm just going to send my, there we go. I'm just going to test it a little bit. Clean column name, and then I'm just going to put, there we go, wheat, gluten-free. Well, it doesn't really matter that I forgot the last E over here, and then I'm just going to add a bunch of garbage. And then there we go. So we're able to see that, we replaced the and just to keep, the semantic of the ampersand, and remove everything that's not a character. And then, so now we know that we have 680 columns. So basically, what I'm going to be doing over here is I'm going to use a quick little trick where when you pass the 2df method, you can pass a list that you unpack with the star, and then sanitize, oops, sorry, it's not sanitize, clean column name, name for name in food columns. Okay. All right, and now if I do, if I look at food.columns, you're able to see that, everything has been removed. And now one of the things that I'm going to look is I'm going to do set, and then, sorry, there we go. And then I'm going to do the length. And I still have 680. So one of the things as I was cleaning the columns, I just wanted to make sure that, there's nothing that's clashing, because PySpark will accept two columns to be named the same if they have an origination that's different. So when you do some join, if they have some tables that have the same column, PySpark is not going to choke too much, but other than that, it's never a good idea. You'll get the optimizer confused, and it's just bad. All right, I think that we are pretty much ready to go. So I'm just going to give a sense of what an EDA is going to look like. I don't want to be like extremely thorough at first. I want to go as fast as possible to go to model. So I'm going to do food select, and I'm going to take Yuka because it's easy to type. And then I'm going to use the summary method, and there you go. So basically, you see that I have, just to give some perspective, there's 5 records that are null, so I don't have any value. The mean is a little bit odd. It's very low, and the standard deviation, there's not a whole lot of standard deviation. And you can see that the min and the max, like it's 0 and 1. So it gives me a good insight that they're binary. And as a matter of fact, most of the columns are binary. So one of the things that I'm going to look is I'm going to create something like a quick exploration, and I'm just going to gather all of the columns that are binary. I'm going to wrap them into a list of features. I'm going to build a quick machine learning pipeline, and I'm going to generate something. So I'm not even going to look at basically sorry, I'm just going to readjust. I'm not even going to look at some of the other features for now, because we just want to have a first pass, and after that, we'll be able to spend a little bit more time. What it's going to provide, though, is I'm assuming that a lot of my features are going to be, a lot of them, if you look like watercress, wasteless, all that sort of stuff, they're binary. So I'm going to have a lot of variables. There's a very good chance that my model is going to be crazy overfit. But as I'm splitting between training and testing, if I have a performance that let's say I'm 70, 80, 90% accurate, well, it gives you a good insight that there's already a lot of signal that you're getting there. If your model performance is absolutely abysmal, well, it probably will mean that you're going to need to do well, regardless, you're going to want to do feature shrinkage. There's a lot of features, but you already have a first pass. Like, use the model as something that you can iterate over and you can explore. I like, my first model is always a throwaway thing. Like, I pick whatever, I build something, and then it gives me kind of like the path is carved. I feel comfortable about continuing, and it's fun. You want to do machine learning. All right, so what I'm going to be doing is I'm going to do food, and then I'm going to aggregate, and then basically what I'm going to be doing is I'm going to select all of the columns that are where all right, I'm gonna take it from the start because it can be a little bit complex. So the first thing that I'm gonna do is I'm gonna do food that aggregate, and then f collect set x. There we go. Perfect. For x in food columns. And then basically what's that going to give me is, and then there we go. And then I'm just going to do, oops, I just pasted show. And then I'm just going to show what it gives. Here we go. B. Perfect. All right, so, first error of the night. All right, so I'm going to, right now I'm not too worried, like import, yeah, that's fine. You can go, yeah, okay. PySpark.sql.functions, that's F, not V. There we go. And then, perfect. And then that's going to look like absolute garbage. Like there's going to be a ton of stuff. There you go. Knew it. And then what I'm going to do is, oh, actually, that's not bad. Like we're still able to look at a couple of things. So if you look at this, and then I'm just going to move a little bit. Let's say 100, move to the right. There you go. So if you look, like Cake Week has more than a couple values. Okay, that's all good. 22-minute meals. Like see, 22-minute meals, 3 ingredients. Like you start to see, like there's only 0 and 1. So what I'm gonna want to do is rather than that, I'm gonna want to basically remove, extract all of the columns that are only with 2. So basically what I'm going to be doing is, so two binary columns equal, and then there we go. And then I'm going to do F when, no, sorry, F size, F collect set, there we go. So this is all good. Equal 2. And then I'm just going to wrap this into parentheses. And then I'm just going to remove the show over here. There we go. And then if I look at this, so binary column. So now I have something that looks a little bit terrible, like size collect, like it's a little bit of a mess. So I'm going to rename my column over here, and I'm just going to call it alias, alias, and I'm going to recall it exactly the same name because I want to preserve those name of the column. So let's take it from the top over here. Just summarize a little bit what I do. For each of my column, I compute the size of the set of the values. And if it's equal to 2, then it gets true, and otherwise it gets false. So basically what it does is it's going to give me a data frame that's going to contain a single row, and that will give me only that's only going to give me the true if the variable is binary, and false if the variable is non-binary. And then basically, the moment that this is going to be done, I can probably get it to pandas, because we can. It's not because you're using PySpark that everything is gone. This is going to be a one line, so I'm basically going to have a data set that, if you look at binary columns, and I'm just going to unstack, and there we go. So that's going to give me, I have my my elements here, and then I have I'm not exactly sure of what this represents, but don't really care about that. And then I have my true or false. So basically, if I continue with that, I'm just going to keep only the ones that are not true, because there's obviously a lot more. Columns that unstack. Basically, this is because it's a series that gives me only the ones that are false. So basically, here they are: title, rating, calories, protein, fat, sodium, cake week, and wasteless. So I'm just going to copy and paste this. Eventually, I'm going to look into doing something a little bit more automated, but we're being a little bit messy. It's Friday. There we go. And then I'm just going to remove this, and then I'm just going to There we go. All right. So those are not binary. And then here we go. And then we need to put some comma. Yeah, probably doesn't matter. I'm gonna let my formatter take care of this for me, as long as the syntax is legitimate. There we go. It looks now all pretty. Another thing to remember is before we go absolutely crazy, I'm gonna get my target, which is dessert. I always put my target into a single cell list, just because all of the rest of the variables is also there. And I put them in capital letter because they're top level variables and they're easy to refer to. Eventually that code is going to get reorganized. You see, I have imports, I have stuff all over the place. It reads more like, kind of a stream of consciousness. But I'm gonna reorganize this as I'm gonna go along. So, all right, now, so basically what I wanna be able to do is, so my, data set, I'm just going to call it data set. I have, it's going to be food dot select. And then I'm just going to keep the variables that are actually even better, variables, which are basically going to be x for x in food dot columns, where x not in not binary, so it's binary, and x not in target. Perfect. What did I do wrong? Oh, sorry, it's not where, it's if. There we go. I'm just gonna bring back my Python. It's not the black arrows that I want to keep. There we go. Okay, so I'm going to keep this over here, and I'm going to go, there it is, variables. So I have a bunch of variables, like a lot of them, a lot. So I'm just going to check just to make sure that my, I tend to be extremely insecure. Sometimes I have 671, 672, 3, 4, 5, 6, 7, 8, 9, 680. All good. I'm accounting for all of the variables. There's no problem. Now I'm sure that dessert is not away. Sorry, it's not in my variable. I can start looking at building my ML pipeline. And this is cool. Like, I find this to be extremely, extremely cool. So, all right. So no correlation, no nothing. I'm not doing anything fancy. I'm just going to just get it over with. So now what I'm going to do is from PySpark ML pipeline, import pipeline from PySpark ML feature, import vector assembler. All right, so this warrants a little bit of explanation. So a machine learning pipeline is a series of stages that you go from your raw data set to a transformed data set. And basically, there's two types of stages. There's a transformer, which is the data set comes in and a different data set comes out. Or there's an estimator, which is a data set come in and a transformer that depends on the data is going to come out. The poster child of estimators is a machine learning model. The data is going to come in, and basically you're telling them, I want a decision tree out of that. What's going to come out is a transformer that basically will apply that trained decision tree. It's not going to be a surprise here. I'm just going to be using a decision tree. Because in the book I'm using a logistic regression, but because I'm not doing any like correlation or anything. Logistic regressions, linear model, it can be a little bit sensitive to especially variables that are highly correlated when it's a decision tree. It doesn't make it less appealing when you're using a decision tree, mind you, but it's just a little less offensive. So from PySpark, ML, if I am not, I just need to remember classification, import binary. I can never remember decision tree classifier. There we go. Oops. Yeah, I should. I probably should save PySpark Twitch just in case. Emacs has been rock solid for me. If you don't use Emacs, you're missing out. I just love it. All right. So now what I'm going to be doing is I'm going to create all of the stages. The decision tree is our decision tree, which is going to be the last stage of our pipeline. There's going to be a vector assembler, which is basically going to take all of those beautiful variables and it's going to put them into a single column. And a vector is kind of like, think of it as like an optimized list. Spark, when you use machine learning, they expect everything to be in a vector. I find this to be kind of cool. It's really, really nice. And because it makes it very explicit about what are your variables. And you can still keep all of your data like, before. So you have your original data, you just improve on your feature vector, which is, one of the reasons why I haven't done any data manipulation so far. So what I'm going to be doing is I'm going to be doing train test, and then what is my data? Food, and then random split. And then I'm basically going to do, I'm going to do a 70-30. I can always change that. And now what I'm going to be doing is I'm going to do my, I'm going to define my model decision tree equal decision tree classifier. Now I am not, I'm not super good at remembering what all of the parameters are mean. Oh, yeah, I should probably import my stuff before. There we go. That's going to make a lot more sense. Boom. See, if you're using IPython, you can just put a question mark at the end. If not, dot underscore doc underscore. And where I'm going to want to go look is over here. So what I need to provide is the feature, the label, the prediction, and then the rest. There's a bunch of stuff like that is already defined. So I'm not going to overthink it. I know that my feature call, I'm just going to call it a feature explicitly, just to remember myself that I need to. My vector that's going to be assembled is going to be that feature. Label, I'm going to call it, I'm not going to overthink it. It's basically going to be target, and then it's going to be the first element. And then prediction, I'm going to keep prediction. Probability, I'm going to keep probability. Yeah, the rest of the stuff is going to stay. I'm not even, I could probably put the seed to something. Let's be crazy. Seed equal 141199. There we go. Oops. Okay. So now I have this vec assembler equal. Now we're going to do our vector assembler. So those are the first one is an estimator. They work the same. The second one is a vector assembler, which is a transformer. I'm going to do the same, although this one I've used so much that I know it by heart. But if I go up, basically you can see my signature is input calls, output call, and how do we handle invalid. I want my stuff to handle the invalid, so input calls equal, basically it's going to be variables, output call is going to be features. All right, and then basically one of the things that I will want to do is before I go, now I know that I have some null values over here. So one of the things that I'm going to want to do over here is basically food df equal food fill na. I want to do 0.0. And then the subset, if I, just a quick moment, food fill NA. There we go. So basically, subset, there we go. So my subset, subset equal my variables, and then where dessert is not null. Sounds good. I'm also removing, I'm making sure that I'm removing, like if the dessert is null, I could put it to 0, but like seriously, do we really want to worry about this? No. So label. All right, so oh, label call. There we go. All right, I'm going to go, and then perfect. And now just for my curiosity, how many stuff didn't have any dessert? Oh, 5. Yeah, so there's 5 records that didn't have anything. So we got rid of 5 records. It's not a big deal. We can probably address them a little bit later. But, you know, we want to be quick. I mean, I'm almost out of time. All right. So now I'm going to do my pipeline equal pipeline, which is the object. And it takes a single parameters equal vec assembler, and then decision tree. And then now what I'm going to be doing is pipeline model equal pipeline. Oops. Fit. I want to do train, and then pipeline results equal pipeline model dot transform test. So this is kind of cool. When you're looking at this, basically remember a pipeline it contains a bunch of stages where there's some transformer and there's some estimators. So the transformer is just go pass through. When you do fit, the estimators are getting trained, so our decision tree model is getting trained, and then it becomes a decision tree model, which is something that is just a transformer. You send some data in, and there's some data with a response that is added out. So I can then, once my pipeline is fit, my pipeline model, I can use to transform it. And as long as the data frame is going to contain the input that you expect, so basically you expect what's going to come into the variable assembler. You're going to expect all of the columns of the variable list, and you're going to expect basically your target. So because the data frame are from the same random split, of course, it makes sense. But it also means that, you know, if you have some data that's coming around, or even if you're doing like streaming prediction, you can go ahead and do this. So, all right. So this is going to train. Oh my God. What am I doing? I am getting, here we go. What is my params must either be param map or done something fishy. Failed to execute user defined function. There we go. Struct type tiny int. Right. We're just gonna see what happened. It's with the vector assembly. So vect assembler transform train. So, all right. So output call is, so what did I, so it contains a vector of double, and this should all be all right. Select feature show. 671, okay. Huh. Oh, encountered null while assembling a row with handle invalid. There we go. So I want to consider remove invalid. All right, so I'm just going to, I'm not going to worry too much about that. So handle invalid equal skip. There we go. So I'm just going to go ahead and do this. I'm going to address this. Basically, you know, this is where, like, you know, this is where I would put like some notes, null handling. There we go. Again. Oh no, it worked. There we go. And then, yeah, results. Boom. So I'm just going to select results column -2. Sorry, with an S. No, -2. There we go. This is the way. I'm going to do -10 just to be able to 5. There we go. Let's show. And then you're just going to be able to see. So you have your feature, we have the raw prediction, we have the probability, and then the prediction. So basically, for those who are new to machine learning, the probability, if we look a little bit bigger, it's the first one is the probability that you're going to land, it's going to be 0, and the probability that it's going to be 1, and both of them sum to 1. And basically the threshold is usually 0.5. So if the first one is over 0.5, it's going to be 0. And if the, like, you know, here we have 95, and then this one we have 0, 1. And then on the raw prediction, it depends on the model, but you know, this is pretty much where you land into the tree. So the decision tree is not super big, so you know, there's a lot of stuff that is going to fall. And now what I'm going to be looking for is, I'm just going to look at my a confusion matrix, and that's going to give us basically a sense of where we stand, and we're going to be able to then continue. So basically, so one of the things with the confusion matrix is that we need to go down to the RDD. It doesn't exist, unfortunately, with the data frame. So the RDD stands for Resilient Distributed Data Set. It's a lower level structure. So I'm just going to import from PySpark MLlib evaluation, import a multi-class metrics. And then multi-class, we can just use it with 2. And then I'm just going to create a prediction, pred, and label equal prediction, select prediction, and then my target, dissert.rdd. So I'm just going to show you what it looks like. Sorry, it's not prediction over here. It's basically I want to be test. No, results. Sorry, results. Up. All right. And then pred and label. There we go. So you have like a map partition over here that basically, and then there's 226 subdivisions. I'm not going to show it just because it's going to be really big, but basically what we have is we have like a bunch of tuples, if you get to think of it, the prediction and then the raw, the real result. And now I'm going to basically create my confusion matrix. So I'm going to there, I'm gonna multi-class metrics, and then I'm gonna instantiate it with the pred and label. So for those who have used scikit-learn, it's pretty similar. Like, you know, you define an object and then you can apply the different methods to be able to see what you want. I could also, you know, the standard approach, we could use you know, other metrics, but I'm a big fan of looking, you know, at the confusion matrix because it gives me a sense of like where I do stand. Here we go. All right. What if they, it's because Cloud Pickle. Oh, is it because I don't have, just a quick moment. There we go. Hopefully that should work. It's just because I all right, I am not able to get what I want out of this. There's a Cloud Pickle error. Doesn't really matter. What I'm gonna do is I'm gonna do it by hand whenever. So if I do results.select prediction, as a matter of fact, results group by prediction dessert, and then count, and then show. All right, so basically 1-1, I have 739. So basically I predict accurately, and basically we can look into, so those ones over here and this one over there. So basically I have a pretty high, like, you know, already, it's already quite high. I'm doing, you know, something quite good. I'm just going to remove this because it's always going to crash. And then I'm going to use something a little bit more summarized. So PySpark ML evaluation, import binary classification evaluator, and then basically what I'm going to want to do is create that evaluator. Oop. All right. Okay, decided to go a little bit crazy over here. Evaluator equal binary. There we go. And then my label column is always dessert. My raw prediction column. So because we're evaluating the metric, I'm looking at the raw prediction. rather than the prediction overall. The prediction overall is going to give you your confusion matrix, but if you want to have finer metrics, I'm going to be looking at the area under the curve. Under receiver up, there we go. Okay, and then all good, and then basically accuracy equal evaluate. As a matter of fact, I can print area under C equal, and then evaluator evaluate test. All right, that should work. I always forget that I have my columns over here. There we go. I don't type fast enough. There we go. And then raw prediction doesn't exist. Oh, it's not. It's because it's not tests. It's results. There we go. Perfect. And then up. Oops. There we go. The result. And then I'm just going to go and look. It's because there's an S. And then what it's going to give me already. So my area under the ROC is 50% at the moment. So it's not incredible, but it's definitely a start. So we're looking at what we're going to be looking for is improving this a little bit. I'm just going to have a look at potentially improving some of the features, removing, especially removing some features, I believe, which is going to avoid a little bit the confusion, trying additional algorithms. So we can probably go back. So what I'm going to be looking for at first is remove all of the columns where you know the count is basically there's not enough differences. So I'm going to do this. There we go, the binary, the target, the variable, this is all good. I'm going to do, okay, so this is step, remove any variable that has less than 10 zeros or ones. And I chose that pretty arbitrarily, you know, as a start. So what I'm going to be looking at for is basically, I'm going to use the same thing where it's going to be the sum of column x alias x for x in basically variables. So this is all good. And then now what I'm going to be doing is food.select, and then I'm just going to put a star over here, and then I'm just going to look at what it looks like. Yeah, show me. There we go. So basically, what we have over here is, you know, for instance, 22-minute meal is 17. So it's always 0 or 1. So, you know, if the sum is 17, it means that there's 17 ones. So I'm gonna do something over here where it's basically count of records. Oops, records count. equal food.count, and then threshold equal, I'm going to do 10. So basically, one of the things that I'm going to be looking for removing this. So basically right now what I have is I have something that looks, quite nice. I'm just going to select the head because I have one single like so count binary. Let me show you what it looks like. It's going to take a little bit of time. Count binary over here. So you have a row, and then basically the row has all of the little bit of things over here. So each field has the number, and then the head basically extracts a row, and a row can be as a dictionary if we use the asdict method. So now I have a dictionary, and then basically what I'm going to be looking for is features that are too rare. So seldom binary features equal. So what do I want to do? So basically I want to keep only, I want to take the columns for, C, for C, num, n, in count binary items. If the n is smaller or equal than the threshold, or n is over basically the records count minus the threshold. And then basically what I'm going to be doing is I'm going to be looking at variables following this. It's going to be equal to the list of variables minus the set of seldom binary features. And I'm just going to go and see what it gives me. There we go. It's going to take just a little bit of time to compute. And basically, how many variables am I losing by doing this? So I'm losing a few of them. Like I'm down to 498. And then if I look at length of the seldom binary features, there's 173 that I'm losing. So now this is quite wonderful. Like, so I can go and rerun my pipeline and then see if my AUC is going to get better. So actually, it became worse. So removing those variables, so although they were quite seldom, it's quite interesting to be able to see that my this is getting smaller. This is getting smaller as we go along. What I would potentially look for would be to include the non-binary features to be able to change the parameterization if we do, for instance. So as a matter of fact, like I could cheat and see, like, random forest classifier, and then just see, like, if I do a random forest instead, classifier, and then see if this is getting me better. But as a matter of fact, we would do cross-validation, we would continue improving on the features. And you see over here, like, this is scary. This is really scary. My decision tree, I know my decision tree was not fancy, but if you're looking, like, my area under my curve, like, it went from 50 to 95 just by changing my algorithm. So In the book, I'm using a logistic regression, and this is closer to the 95 mark. I mean, as a matter of fact, I can probably go and fish. What was my, yeah, my, when you're doing the model that we're doing in the book, like we're getting an accuracy of like 99%. There's two reasons for this. Like, first of all, it's not hard to predict if something's going to be a dessert. Like, if you close your eyes and you're asking yourself, if something contains caramel, will it be a dessert? Yeah, good chance. If something contains herring, will it be a dessert? Not so sure. But this is, one of the thing, and actually, it's kind of it's kind of pretty cool. You see, I've just changed one of the because the interface is so consistent. Going from decision tree to a random forest is super easy. This would not be the end. If we're looking at this, of course, I would not, say, okay, my job is over. But I really recommend you to take that approach when you're doing data science. Start small, and like if you're looking at this over here, what we've been doing today is like, it's less than 100 lines of code. Like, I'm at line 95 over here, and there's a lot of spaces. I would probably, reorganize this code, put all of my imports at the top, document what this is doing, modularize this a little bit to make it more easy to think about. And then I would just continue doing those iterations. So if you're interested, this is the chapter called A Foray into Machine Learning. Some of the stuff that we didn't get a chance to look is how to chart, those insights, how to extract, the parameters, which one are the most important. You can also, build a hyperparameter optimization pipeline using, cross-validation. And finally, you can create your own bespoke features. And this is where, Python and PySpark becomes especially desirable, because Python has a lot of, neat libraries that you can use for that. And you can distribute it with Spark if you're interested about it. My previous Twitch, which was last year, talks about user-defined function, so how you can integrate PySpark into how to integrate Python and Pandas into PySpark. But yeah, it gives us a pretty good, interesting start. And yeah, if you have any questions, I'll put my email into the chat. There is also, if you don't have my book right now, there's a 40% coupon that I'm also going to put into the chat. Don't hesitate to reach. I'm always happy to see what kind of cool stuff are you doing. And then the very best way to get started is just to, pick a data set and get started. This one I'm a big fan of because I find it completely silly, predicting if something is a dessert. But, pick something. Have fun, and as you can see, even on a local machine, there's a lot you can do. Start small, and then you'll see, like, PySpark's going to scale with you, like up to terabytes and more of data. All right, so I'm going to wish you a very good night, and it was really nice to be able to code with you, and I will talk to you soon.